Number 7 and 8 is where it gets a little bit trickier. This is addition and subtraction, and unlike multiplication and division, addition and subtraction, I have to get common denominators. And right now, it's impossible for me to, or just about impossible for me to tell what the least common denominator here is until I look at the factors of this thing, until I see what each of these denominators is made of. So the first thing I'm going to do is I'm going to factor. So I build my bridge. That's going to be an x minus 4 times an x plus 2. Minus. Over here, this is going to be a 3 over. Again, I'm going to build the bridge and I'm going to factor. That's going to be an x plus 5 and an x plus 2. And see, now I can see the factors. I can see they already have an x plus 2 in common, but they need to have all of the same things, all right? So they need to have all the same factors. And again, getting common denominators here is a little bit like raising children. We have to be fair. So if I look at this first denominator, this child is saying, Ma, it's not fair. I've only got an x minus 4 and x plus 2. He's got an x plus 5, so I want an x plus 5 too. Okay, see the other denominator's got an x plus 5, and that's not fair. This denominator wants an x plus 5 too. So we're going to give him the x plus 5. But now this denominator over here is sad because the other denominator's got more stuff than he does. And he says, Ma, it's not fair. I've got an x plus 5 and x plus 2. I want an x minus 4. So we say, okay, you can have an x minus 4 as long as you sit there and be quiet. So we're going to give him an x minus 4 also. So now it's fair. See, and we're just making sure that they all have the same stuff. All right, and I've wrote this much bigger than I've written this much bigger than I should have. I'm taking up too much space for my next example. Let's see if I can condense it a little bit. Don't mind me. All right, so now we're going to multiply this by the x minus 4 over there. See, now everything's fair. That is a terrible looking x. Let me try again. Because now each denominator has the same thing. They each have an x plus 5, they each have an x minus 4, and they each have an x plus 2. Now it's fair. So now over here I'm going to distribute the x. So that's going to be an x squared plus 5x all over this entire denominator, which is x plus 5, x minus 4, x plus 2. Minus, so I'm subtracting. Over here, again, I have to distribute the 3. So that's going to be a 3x minus 12 over x plus 5, x plus 2, x minus 4. And now that I've done this, I can subtract. I can actually do the subtraction here. Again, I'm subtracting these two values. There's subtraction between. And if I'm worried about making a mistake, let's change it to adding the opposite. So instead of subtracting, I'm going to add the opposite. Okay, and that makes everything in that numerator the opposite. Now I just have to combine like terms. That's going to be an x squared, a plus 2x, and a plus 12. I add the numerators. Denominator stays the same. Okay, so since they have the same denominator, I'm just going to use that same denominator. And it doesn't matter what order I write these in. It's still the same thing. The last thing I can do is try to factor the numerators to see if this reduces, but this one's not going to. Okay, so I'm going to leave it just the way it is. And that's it. If I look at the next one, again, I start with the same thing. I'm going to factor everything completely. So this is going to factor into, I should give myself just a little bit more space. It's going to be an x minus 2 over, this is going to factor into x plus 3 and x minus 3, because that is a difference of squares. So I factor the difference of squares. And then this is plus, this is going to be an x plus 4 over, I build a bridge, this is going to factor into x minus 4 and an x minus 3. And now once again, we compare them like children. And we look at the first denominator, and the first denominator says, Ma, it's not fair. I want an x minus 4 too. So we say, okay, you can have an x minus 4, since of course the other denominator had an x minus 4. See, now things will be fair. But now they're not fair, because now the first denominator has too many things compared to the second. So now the second denominator is going to say, but Ma, I want an x plus 3. So now we're going to give him an x plus 3, because that seems fair. See, now each denominator has all the same stuff. They each have an x minus 4, they each have an x plus 3, and they each have an x minus 3. So now everybody's happy. All right. In the numerator, up here, I'm going to have to distribute, okay? Or if you want to call it FOIL, that's fine. Same thing over here. I've got to distribute. I've got to FOIL. All right, and the reason I have to do that, if I want to add these things, I need to be able to see my like terms. I can't see them right now. So now I got to multiply. That's going to be an x squared minus 6x plus 8. The denominator is going to be this whole thing, x minus 4x plus 3. Yeah, it's tough to be fair, you know. You got so many things you have to deal with now. Again, I'm going to multiply. It's going to be an x squared plus 7x plus 12. The denominator, again, it's going to be this whole thing. And now it's just addition. I just have to combine like terms. X squared and x squared, that's a 2x squared. The negative 6x and the plus 7x, that's a plus 1x. And the 8 plus the 12 is a plus 20. And then, of course, the last thing I can do is build a bridge and try to factor that guy, but it's not going to factor. So I added the numerators. The denominator stays the same, and that's it. I can't reduce this because the numerator doesn't factor, so that's my answer. Okay. If I take a look at this guy, remember when we're graphing these things, the first thing I always want to do is I always want to find my restriction. So I'm going to take this denominator, the x squared minus 1, and I'm going to set it equal to 0. So now I got to solve this by factoring. This is going to factor into x plus 1 and an x minus 1. And now I'm going to set each factor equal to 0. X plus 1 equals 0 and x minus 1 equals 0. And I'm going to solve each. So here I subtract the 1. I get x cannot equal a negative 1. Here I add the 1. I get x cannot equal a positive 1. And now from here, in order to get the vertical asymptotes and the holes in the graph, I've got to factor this thing completely. So that's my domain. The x does not equal the negative 1 and the positive 1. And really my vertical asymptotes and holes in the graph are going to be one of these things. Each restriction is either a vertical asymptote or a hole in the graph. All right, so to find out which one is which, I have to factor this thing. So in the numerator here, I'm going to build a bridge. That gives me a negative 10. So the two numbers that multiply together to give me a negative 10, but add together to give me a negative 3, that's going to be a negative 5 and a positive 2. And notice, again, I split up the middle term. Because the 2 out front, I can't do a shortcut here, so I'm going to do my factoring by grouping. So I group the first 2 together, I group the second 2 together. Out of the first 2, I can factor out an x, which is going to leave me with a 2x minus 5. Out of the second 2, I have to factor something out, so here I'm going to factor out a plus 1, which leaves me with a 2x minus 5. And now my two factors are the 2x minus 5 and the x plus 1. Okay, so that's what it looks like when I factor. So now I'm just going to simplify this thing. In other words, right here, the numerator factors into 2x minus 5 and the x plus 1. The denominator I already know factors into x plus 1 and x minus 1. And now I just reduce. The x plus 1's cancel out. So essentially what I'm going to be graphing is the f of x equals the 2x minus 5 over the x minus 1. Okay, that's essentially what I'm going to be graphing, but again, the original problem gives me the holes in the graph, okay? That's what's important about it. So now from here, each restriction is either a vertical asymptote or a hole in the graph. So now look at my restrictions. If I look, first things first, the x plus 1, this guy right here, got canceled out. The x plus 1 is what gave me the restriction of the negative 1. So since that restriction essentially got canceled out, that's my hole in the graph. Okay, the one that gets canceled out from the original problem is my hole in the graph, so that's the negative 1. All right, that's the x value for the hole in the graph. To find the y value for the hole in the graph, I just have to plug this back in. I plug the negative 1 in. So right here, I'll plug it in right here. That's a 2 times negative 1 minus 5 over the x, which is negative 1 minus 1. So that's going to be a negative 2 minus 5 over a negative 2. So that's a negative 7 over a negative 2. Negative divided by negative is a positive. So it's a positive 7 halves. Okay? Not very appealing to graph, but that's okay. We'll use that as a little bit of a check. So the next one, if I look at my next restriction, the next restriction came from the x minus 1. And the x minus 1 is still in my function. Okay? It's still part of this function. Since it didn't get canceled out, that's my vertical asymptote. So that's the x equals positive 1, because that restriction, that factor, is what gave me this other restriction, the x equals 1. The next thing we have to look at is the horizontal or oblique asymptotes. For horizontal or oblique, really we just compare the degree as the numerator and the degree of the denominator. Okay, and when we say degree, we're just looking for the highest exponent term. Okay, so here the degree is 2 because that's the highest exponent. Here the degree is 2 because that's the highest exponent. All right, so the degrees are the same. When the degree of the numerator and denominator are the same, it means that I'm going to have a horizontal asymptote, so no oblique this time, and it's going to be y equals, well, when they're the same, we just divide the leading coefficient, and that's the number out front. So up here it's a 2, down here it's a 1. Okay, I just drew it in there. So I divide those numbers. 2 divided by 1 is 2. So it's y equals 2. So that's my horizontal asymptote. Now I'm going to graph this stuff and then go from there. The vertical asymptote is x equals 1, so that's right here. The horizontal asymptote is y equals 2, so that's right here. And now from here, I just have to find out where my graph's going to be. I'm just going to set up an XY chart. So I'm just going to do an XY chart here. So over here, when I look at this, really, since the vertical asymptote is at x equals 1, I just need a value from each side of that. So if I go to the left, I'm going to choose the point 0. If I go to the right of that line, I'm going to choose the point 2. So I'm just going to choose those 2 points to plug in. So I'm going to plug the 0 in, so it's 2 times 0 minus 5 over the 0 minus 1. So that's going to be a negative 5 over negative 1, which is a positive 5. So that's one ordered pair. Now I'm going to plug the 2 in. If I plug the 2 in, I have 2 times 2 minus 5 over the 2 minus 1. So let's see, that's going to be a 4 minus 5, which is a negative 1. And this is going to be 2 minus 1, which is 1, so that's a negative 1. And I'm going to plot each of these points, so I come back up here. The 0, 5 is going to be right here. The 2, negative 1 is going to be right here. And that gives me an idea what this thing's going to look like. I'm going to hug this line, go through the point, hug the line. Okay, I'm going to do the same thing up here. I'm going to hug this line, go through the point, hug the line. And then from there, I just have one more thing to do, and that's my hole in the graph. So I go to where x equals negative 1, which is back here. So right here, that's where x equals negative 1, because that's the line negative 1 right there. And I put my hole in the graph, and that was a terrible looking. Let me try again. There, that's much better. So I put a hole in the graph, and now my quick check, does that look like the ordered pair negative 1, 7 halves? Okay, keep in mind that 7 halves is 3.5, right? And I go up 1, 2, 3. Yeah, that looks about 3.5. So now I know my graph is kind of in the right place here because my hole lined up with the ordered pair that it was supposed to. Okay? If I take a look at this next one,